Happy Friday, students. It's AMI day 25. Mr. Seal here with your overview. Today we're talking about heat and temperature. Specifically, we're talking about specific heat. So let's get into our reading and then break it down. Okay. So imagine this. Imagine you are running across hot sand towards the ocean. You run to the water's edge, but you don't go any further because the water is too cold. How can the sand be so hot and the water be so cold? The sun is shining on both of them. It's heating both of them. The answer is that water requires more heat to raise its temperature than sand does. When an object is heated, its temperature rises, but temperature does not rise at the same rate for all objects. The amount of heat required to raise the temperature of an object depends on the object's physical properties. Okay, physical properties are things like density that we've talked about, flexibility, smell, color, shape, mass, and volume. Those are all physical properties. We have a nice diagram here. Boiling point, melting point, specific heat, state of matter like solid, liquid, and gas, texture, luster, how shiny it is, solubility, how quickly it dissolves in water. All of these are physical properties. Let's continue. Specific heat is a physical property of substances. The specific heat is the amount of energy required to raise the temperature of 1 kilogram of any material 1 degrees Celsius. Okay, so first let's talk about heat versus temperature. Temperature is the measure of how hot or cold something is. It's the average kinetic energy of the molecules in the object. Okay, heat is the actual energy that raises or lowers something's temperature if it's added or removed. So some materials, like water, require a whole lot of energy in order to raise the temperature. If you've ever boiled water, you know that this can take forever unless you add a ton of energy. Okay? So we have here a table listing the specific heat of different materials. Now, the specific heat is measured in joules. That's how we measure energy. Just like you might use volts or watts to measure electricity, you use joules to measure the energy of heat. Celsius we would use to measure the energy, or to measure the temperature. So specific heat is joules per kilogram. Okay, kg is kilogram. So for instance, aluminum would need 903 joules of heat energy to raise 1 kilogram of aluminum up 1 degree Celsius. So to go from 20 degrees Celsius to 21 degrees Celsius, we would need 903 joules of heat energy. Okay, and then look down here at ice. Okay, notice that ice and water are not the same. Interesting. Okay, ice 2060 joules, water 4,180 joules to raise it 1 degree. Okay. All right. Let's look at our questions. Okay. In graph 2.5, what is the dependent variable? All right. So we look here. Here is graph 2.5. We have down here at the bottom, we have water, sand, and iron, 3 different materials. And then we have our heat in joules on the left. Okay, so we read our title, heat needed to raise 1 kilogram of each of these materials by 1 degree. In this case, it's Kelvin, but that works for the same thing. Okay, so this is still about specific heat. So what is our dependent variable? Okay, is that the 3 types are 3 different materials, or is that the amount of heat energy it takes to raise each of those materials by 1 degree? Okay, the specific heat. Okay, so that's graph 2.5. Question 2. How much heat is required to raise 1 kilogram of water by 1 degree Kelvin? Okay, so for this question, you could use the graph. The information is there in that graph, or you could use it back in table 2.5. Specific heat of common materials, find water, and find its specific heat. Right, either one. Question 3. What is the relationship between table 2.5, specific heat of common materials, and graph 2.5, heat needed to raise 1 kilogram of material 1 degrees Celsius or Kelvin. Okay, so what is the relationship? I'm asking you, how are these two things related? What do they have in common? What do both of the graph and the table do for us? And question 4, which model, okay, the graph 2.5 or the table 2.5 is best for doing calculations? Why? So if I were asking you how many more joules of heat does it take to heat sand 1 degree or iron to heat 1 degree, which one would be better to use for doing that calculation? Would you use the graph that has sand and iron, or would you use the table that has sand and iron? Which one would be better for doing calculations, to do some math to figure out specific heat, differences in specific heat, etc.? Okay. And then why would you choose the graph or the table? All right, guys, that's all for today. Let me know if you have any questions, and I'll see you online. Happy Friday.